Good afternoon, everyone, and welcome to this session. The session title is You Too Can Secure OT. It is my absolute honor and pleasure to introduce two speakers for you this afternoon, and I've also heard that this presentation is pretty powerful and pretty packed, so you'll be delighted and entertained the whole time. And secondarily, the speakers wish to give 10 minutes at the end for questions and answers. So be ready for that. So I proudly introduce to you Amit Heineman, Senior Network and Security Solution Architect, Rockwell Automation, along with Diane Golden, System Security Architect, Rockwell Automation. Thank you both.
Thank you. Good afternoon. I hope you're enjoying the conference so far. We've got the standard RSA disclaimer slide. Now, Amit, you visit a lot of customer sites. What do you typically see in OT networks?
Yeah, so if we take a look at the graph on the left, this is representative of what we see in a lot of the manufacturers out there with legacy networks. You know, some of them are TCP/IP based, other ones are running a serial, some proprietary network. So that's very commonplace, and you'll still see that even in facilities that, modern facilities that are operating today that have, upgraded certain components. But what we're going to talk about today is that shifting from that side, flat networks, which again are still out there and a lot of our customers, to this segmented, monitored, controlled network that we see on the right.
And OT networks, or OT systems, if you're not familiar with them, can be broadly categorized into two large groups. The first one being discrete manufacturing. That's what you typically think of with your assembly lines. So if you picture automobile manufacturing, anytime where you're putting something together or you're making individual widgets with a series of steps, that's discrete manufacturing. The other major category is process. And process systems, these tend to be large. Think of mining, think of oil and gas, think of chemical processing. A lot of these systems like water, wastewater, they're continuous processes. They can never shut down. How many of you like it when the power goes out at home? Oh, no hands? Or if you turn on the water and the water doesn't come out of the faucet. So these systems have to be constantly available. And similarly with those discrete systems, as you're all aware with the supply chain crisis, these manufacturers are under a lot of pressure. Uptime is critical. So, if you ask your plant managers, they will be able to tell you, likely down to the minute, how much it costs if a machine or a line is not running. These are key things to know in the OT space. And there's also a hybrid between these two things. So if you think about like batch processing, making pharmaceuticals and then packaging them in saleable containers. So a lot of things fall into this hybrid, kind of a blend of the two. And then just major differences between OT technology and IT technology. IT technology, you hear a lot about data breaches. We want to stop data breaches. OT, confidentiality is not that important. It's important for some things, like keeping private keys, keeping things that are secrets safe. But for the most part, availability, safety, and keeping the systems constantly available with high integrity, that is number one for OT. Whether or not something's encrypted, confidentiality, it's just not a priority. And you look at the IT systems and a lot of the technologies, off the shelf, homogenized, similar couple of operating systems or manufacturers. OT systems have a lot of proprietary architectures. They speak a lot of unique protocols. And you'll see protocols that you don't see on the IT side. So legacy systems like DeviceNet, ControlNet, you'll see Profibus, Modbus, you'll see Ethernet IP. You'll see all of these things where it's good to know, hey, this is an OT protocol, because you don't want that protocol to be coming from your IT networks into your OT network. So it's important to be able to flag it and know what you're expecting in OT. And then, these products and systems are designed to run for, in many cases, 20 plus years of continuous use. In some cases, these things are buried in the ocean, and literally no one can get out there to service them, so reliability is key. You're not going to be replacing them every 3 to 5 years like your cell phone. And critically, these are cyber-physical systems, So any outcomes here that you're worried about, you're talking about safety, you're talking about explosions, robots injuring people. It's a much more impactful reality versus just losing data. I'll turn it over to Amik here.
Yeah, so as we go through the solutions here today, we're going to talk about this defense in depth architecture. And this is really nothing new. This has been out there for a long time. We're going to, of course, we're not going to have enough time today to cover everything, but we're going to start off, with the, we're going to make our way down to the device. But if you look at the device, you go to the application. So the device is going to be that one of the technologies we're going to talk about is SIP security. The ability to deploy integrity and confidentiality from the controller down even to the I/O module. We'll talk about application-based security, which can be role-based access control. We'll talk about a capability there. Computer, so endpoint protection, looking at zero trust deployment there. Network layer, so now we're looking at access control lists, intrusion detection systems, specifically for OT, and we'll talk about some of the delineation between a traditional IT-based IDS and looking at an OT-based IDS. And then physical, and then on top of that's the policies and procedures. And I think one of the pieces that's missing on that policies procedures, especially on the OT side, is looking at business continuity and disaster recovery plans for OT, right? Oftentimes IT that exists out there, but you look at OT and, as part of that is also patch management. We'll talk about that a little bit as well. Next slide. So this is the NIST cybersecurity framework that we'll use to address some of these different areas. And like I said, we're not going to talk about everything here. In fact, we'll skip patch management, but I'll reference that in a couple of the other areas as well. Good, next slide. So asset inventory. This is, oftentimes, you always hear that you can't protect what you can't see in that manufacturing space. And unfortunately, there's a lot of, if we look at traditional OT systems, especially when you get down in that quadrant on the right, where you see a switch and you've got a set of controllers, getting visibility down there can be really tough. I'll talk about a solution that can be deployed. What I've got represented here is a typical, if you look at any of the OT intrusion detection systems out there, they all have some form of this, right? We're either capturing that traffic, spanning that traffic, and if you look on the my far right, your far left, the problem with that is that not all switches have RSPAN capability, and I'm introducing more traffic on the network. So it's typically recommended that we deploy something either in the middle two where I've put an external sensor in there. I'm spanning that traffic to that sensor, pre-processing that data, and now setting metadata up to be ingested at that OT IDS solution. Oftentimes you'll see an enterprise management console view, which we've got on the very top, to view how my different facilities are performing. And the OT IDSs can perform integration to existing SIEMs out there, syslog, events as such. If we look at this third quadrant over on the right, there, depending on the vendor OT IDS solution, you'll see the ability to put a sensor natively in that switch. So the problem with that, or what can be a problem, is that, especially when we talked about the legacy systems out there, is having the infrastructure to support that capability to put that sensor natively. Obviously, it works out great in a greenfield facility. If you can plan for that, look potentially at that type of solution. And then some type of, there I've got another on the far right, we've got an edge solution to look at, this case it's running on a Windows compute platform, to perform some protocol-specific active scans. And this isn't a Nessus scan or an Nmap. I'm looking at using OT-specific protocols to bridge down through that backplane, out that other Ethernet module, or out that other non-TCP network to be able to paint and tell me what's out there. And that'll come, when we get to vulnerability section, I'll reference that again, because one of the issues that we see oftentimes in manufacturing is they use that controller as a way to segment the network. So I may not see traffic. If all I'm doing is spanning that traffic at that switch level, I'm not going to see that traffic down below the controller. All right, next slide. So this is an example of an agnostic OT IT discovery. So, a lot of the vendors out there have this capability to provide, of course, this depends on my ability in the previous slide where I showed where we're monitoring this network, right? If all I'm monitoring this is at the distribution or the core switch, I'm gonna miss a lot of that traffic. So that's just an example of an OT IDS visibility from a graphical representation. Go ahead, next slide. And here we can see a representation of visual. I like this one because it gives us that Purdue kind of reference model and say, where are those assets located? You could filter by protocol, you could filter by manufacturer to get a sense for that data flow, right? So if we're capturing that traffic passively, then we get a chance to understand what that data flow is. If I'm just doing protocol-specific active scans, I'll be able to tell what those devices are out there, but I might not be able to tell how they're communicating and what they're communicating with. So it really is kind of a balance between both of those solutions to really get the best visibility in the industrial control system. Go next slide. Okay, vulnerability. So again, having some way to correlate that install base. So that's the first piece. And now I say, okay, what's the latest vulnerabilities associated with this? Go ahead and go to the next slide. So I sat through a session this morning by Dragos that was very good, talking about vulnerabilities, right? We can't just say, go patch everything. And one of the problems that we've seen, especially in the OT space, is this misclassification of those assets. So by having a combination of active and passive scanning, then I get my best kind of inferences to what those devices are and can minimize the number of false positives. So it might be a little hard to see, but in this case, this vendor has full matched, right? So are we saying that's 100%? You're not going to run into that? No, but it's a good indication that, hey, I know the rev level of that module, I know the manufacturer, and that just becomes one data point in my overall risk evaluation. Do I patch that system? How do I mitigate that? What is the vulnerability? Okay, go to the next slide. And one of the other things that oftentimes we overlook is longevity status. We have 40-year-old controllers out that are still being used today, and some of them in critical manufacturing areas. And so getting visibility into, obviously that one's pretty easy to detect. You probably don't have a lot of people don't have anybody on staff to even know how to program that thing anymore. And we'll talk about how do we protect an asset a little later. But this just, having the ability to provide life cycle status of those modules is also key, right, of those devices. So here's just an example. This happens to be 2 Rockwell devices that are on our end-of-life status. And in this case, you can filter by, the 5 assets or 3 assets and then 4 assets there. Okay, next slide.
So now I'm going to move into a little bit of high-level risk assessment. So you're probably familiar with doing risk assessments on the IT side. If you're doing a risk assessment on the OT side, you really have to look at those cyber-physical impacts. And like Amit mentioned, we can't necessarily just keep patching and patch everything. We need some way to prioritize what we want to patch and what we don't need to patch or we can control with other means. So if you're not familiar with the international standard IEC 62443, there is an entire section, 3-2, on how to do a high-level risk assessment for OT. I highly recommend you take a look at it, but the first thing they do is identify the system under consideration. That's what the SUC stands for. So from there, we're kind of showing an example of looking at your whole network, pick out a particular zone. So in this case, we pick the material handling zone that we're going to analyze with our risk assessment. And so once you've looked at that zone, look at how it's interconnected within your system. Really, the first thing is trying to figure out, is your current risk level already within your acceptable risk level or not? And you want to look particularly at things like safety impacts. So that you see in this example, there's a safety controller, a robot arm in there. We're showing an example from a manufacturer here. But really kind of honing in on the system. How does it communicate in and out? Can you identify, what's the impact to that robot, or what's the physical impact if that system is manipulated? And then we can kind of put this into a qualitative risk assessment. There's actually a lot of research going on now, and I'm sure you can talk to multiple vendors on trying to make a semi-quantitative risk assessment for OT. But right here, we're just talking about the typical qualitative heat maps. It's great to go talk to your plants, talk to your maintenance folks, ask them, hey, what if it breaks is a bad day for you? You're trying to get to those crown jewels. What's the really impactful things that you may have overlooked that can really cause you a lot of downtime in manufacturing? And the key thing here is on the far right of that chart, health, safety, and the environment. These things are what's going to make things show up as red in your heat map as high risks. Anything that could cause a fatality, anything that could cause an environmental disaster, those things need to be prioritized. You also can look at that financial impact, and like I said, manufacturers track operating time. They can tell you down to the minute in many cases how much they are losing if the system is down. So that's a good thing to get that data from your various plants to figure out, okay, which plant is most critical based on uptime needs. And then your general operational risks as well. You kind of want to map all of these together. And the key thing is just that you're relatively consistent in your risk mapping so that you can get a relative priority in terms of what you want to go and attack. Oh, I should also mention on that one that this is where you can make friends in risk assessment because there's a lot of grants out from various federal governments, state governments, et cetera, for cyber infrastructure resilience. And if you identify key risks, you can actually go and apply for grants to get upgrades for your manufacturing facilities based on improving cybersecurity. And a lot of times, the operational folks have very limited margins for upgrades. So if you can use the risk assessment, you can actually use it to justify new equipment.
Okay, so now we're on to the OT security measure and countermeasures and deployment section. Go ahead, next slide. So one of the things that we talk to, I spend a lot of time talking to customers, helping them secure their industrial control systems, is this idea of this segmentation. And we see this being called out by, we've referenced IEC 62443, which is this holistic kind of industrial cybersecurity standard. We see it called out, and depending on like critical infrastructure, requirements for certain industries to have that clear demarcation, that segmentation between IT and OT. This can be a little challenging here when, especially nowadays with all the devices that are IoT-based, that want to phone home with remote access solutions. But the whole idea here is that I should minimize the dependence of anything in the process control space with IT, right? And have ability to inspect that traffic and ideally go through some type of proxied service for that traffic. So trying to minimize, I should be able to decouple OT and IT for some time. I might have a historian server just buffering data until that enterprise connection is reestablished to jump to that PI-to-PI exchange server. But I shouldn't be reliant on anything from the IT side. So IDMZ, industrial demilitarized zone, is something that IT has been deploying for years on the IT, right on the perimeter edge between the internet and the facility. And we're just dropping that down a layer before the manufacturing side. Okay, next slide. So this is another thing that has been 802.1x has been out there a long time. And in certain manufacturing facilities, especially greenfield facilities, we've seen this implemented. Can be a great solution. The challenge is what we see here on the right is that it's typically a computer-based industrial control system. Devices natively, or majority of them, don't support 802.1x. That authentication piece, do you have access to join this network? So we have to have a way to classify those assets. One method is using SGTs. Cisco has a solution. Other people can utilize that. A way of informing, go to the next slide, where we can, I guess I don't have it, where we talk about that classification of those assets, and then based upon that SGT, you can develop rule sets. Some of those can be dynamic access, that generate dynamic access control lists to restrict that traffic. Next slide. MACsec is another one that a lot of the newer switches support MACsec. If we want to do encryption at layer 2, point-to-point, that can help in that defense in depth strategy. Next slide. Or this zone-based firewall. So this is, I talked about the legacy assets. So, Rockwell has a controller that we use that's 40 years old, and it's still being used in industrial control systems today. So there was no security in concept in mind when that controller first came out, right? And some people say, well, we've got security through obscurity, right? And that might be true to some cases. A lot of people don't know what that is, how to program it. hopefully you've got a backup or some maybe system integrator that knows what they're doing with that. But this is a good use case for maybe a next generation firewall, especially if that is a real critical system, right? So that layered, identifying what the vulnerabilities are, and in fact, like some of those older controllers, they're completely vulnerable, but you're not going to find a CVSS on that PLC5, for example. But it's critical, right? It's a critical component of that manufacturing. So I might want to put a next generation firewall in front of that to not only allow the traditional 5-tuple rules, but maybe from that engineering workstation, I'm going to say this person, based upon their role-based access control, is allowed to go online with that controller, but not download or not go update the firmware remotely. We're going to make sure that person has to do that on-prem. The other thing that we see this classification, that I have SL2, security level 2, that's a 62443 classification. You'll see several manufacturers will get certification, typically by TÜV or maybe ISA Secure, against that standard, and there's levels between 1 and 4 might kind of be in that nation state type attack. So that's what that SL represents there. Next slide.
So the next way you can secure down to the device level is really these more modern devices natively support secure communication protocols. So we're showing here an example of the Open Device Vendors Association's SIP security protocol. So this is basically pushing TLS-based communications and DTLS down to the lowest level 0-1 layer devices. So you can today actually set up a TLS communication secured between a variable frequency drive and a controller. It requires newer hardware, but this hardware has been available for 2, 3, 4 years, depending on which type of device it is. So, and this is showing the ability to push authentication into the devices, so you've set up a secure channel, you're talking to the device you think you're talking to, integrity between those devices, it uses HMACs. You can optionally encrypt the traffic. I say optionally because most OT networks, it's really the integrity and the authentication that is most critical. Confidentiality, in some cases, you might not want, particularly if you're trying to get deep packet inspection, full visibility. So when you push policy down to these devices, you can actually choose which type of policy you want. And you can segment and say, okay, I want this zone to talk to this zone, or this device to talk to this device. It's all based on X509 certificates provisioned in the devices. And this is really the way that OT technology is going, is to bake secure protocols so that you can authenticate all of the endpoints down at the devices. And then at the application layer, this is really where we're enforcing that role-based access control, so the human user, essentially. And this is very powerful. We basically link, in the Rockwell Automation example, Microsoft Active Directory to FactoryTalk directory. So if you're familiar with protecting your domain controller, the FactoryTalk directory is the OT equivalent. You want to protect that and keep that very nice and controlled, because that's got all your role-based access control. You can map that to Active Directory groups. So you might have a group of operators, a group of maintenance staff, a group of engineers, and then once you go into the FactoryTalk directory, FactoryTalk security, you can say, okay, this type of user, this group, has privileges to read the program, but not to modify it. Or this type of user is authorized to change the backup schedule. But you can, so many different knobs you can turn in terms of what you want the various roles to be able to do in the system. And this is all enforced via Active Directory, so you can do single sign-on for your users, make the user experience nice, but really get fine-grained control in terms of who can modify and interact with those devices. And then similarly, you can, if you have confidential proprietary programs you don't want to get out of those devices, you can secure your own source protection on your code. And this is encrypted and backed by the hardware keys within the device, so that if someone were to take that device out of your system, they wouldn't be able to actually decrypt and read that. And then another way you can secure your systems, a lot of times people come and they say, I've got these legacy operator interfaces. Maybe they're running, Windows CE or some outdated operating system, and it's very concerning. An easy way to do this, if you have the opportunity, is to go to thin clients. So you're not putting those legacy operating systems in your plant. You're just, going to a client-server type architecture where you can update the servers more easily, but your actual clients are thin clients. So it becomes much easier for you to secure them. You can go to containerization, and you can really centrally manage all of your operator interfaces this way. It also enables you to lock down things like USB ports and make sure that the hardware is secured. Another thing that we see, as Amit mentioned, the world of IoT. So we see the industrial Internet of Things is already here. People are already connecting devices to the cloud. And if you're concerned about how do I manage these devices, you really need to have edge orchestration, which enables you to manage a whole fleet of devices across all of your plants. So this is, you can deploy this on industrial compute surfaces. You can pick hardware that supports full disk encryption that has a TPM in it so you can have secured measured boot. And you can deploy containerized apps to these, all from like a single SaaS-based application where your admin can say, okay, these are the apps we're going to allow in this facility. You can monitor and see what all the operating system firmware updates of those devices are, and make sure that if anything is powered off, the next time it's powered up, it's going to be pulling the latest updates. So this is kind of fleet management for your OT devices.
Okay, now on to the real-time threat detection and monitoring. Again, going back to the same type of topology we've shown over and over again. One of the other things, if we're properly monitoring that industrial control system, and assuming we have 100% visibility, and we can, with a combination of protocol-specific, active and passive. Now, specifically for that threat detection, that's going to require the passive detection, right? We need to understand that data flow. We build up a baseline to say, here's normal behavior, and then we're going to trigger an alert based upon deviations from that baseline. So there's signature-based, heuristic, there's anomaly threat detection. A lot of vendors have different solutions in that space, and building that baseline, I think, is key, as well as understanding, and putting the sensors out there so you can build out that monitoring. Many of the systems integrate with existing SIMs out there, as well as syslogs, right? So I would deploy, if you're looking for one of the key differentiators between a traditional IT IDS solution and an OT IDS solution is that understanding of those industrial protocols. So one vendor I know has 218 different industrial devices and protocols that are supported and by that package. So it's looking at the data, we're capturing that traffic, ingesting it, classification of that, and then building up kind of that specific inventory and associated, what's quote allowed and what are we going to alert based upon. And then existing SIEMs out there, I talked about that. Full REST APIs is often a common piece that you'll see with any of the OT IDS solutions out there, as well as a lot of third-party integrations with the partners that you see on the floor tonight. All right, next slide. So here's an example of what we see. So you hear, it's pretty hard to see, but there's a ConfLicker code shell. There's one I really like at the very bottom talking about, hey, there was a connection made for the first time by this asset that was being managed remotely. Go to the next slide. We'll get a graphical representation of that. So here we can see that it started out, and we're looking again at that Purdue level, and we can see an asset that started scanning for 3389, right? Looking for RDP, open sessions out there. Then saw, okay, we went down to level 2, found an asset they could connect to, went down, and from that asset, while that asset was being managed remotely, then downloaded that configuration change. Now, if we've done a good job of establishing that monitoring within our network, we'll be able to tell exactly what change was made, right? And compare, here's normal behavior. And if it wasn't for the RDP scan, that might be normal behavior. It might be an engineer that has never downloaded to that controller before, that was outside of that baseline, and then we go, oh yeah, we just need to add that to the baseline. But building up kind of this story of taking these events and collecting those together and presenting that is a key function that makes it easier to identify and mitigate that issue. Okay, next slide. Syslog. So Diane talked about, in this case we're showing a Rockwell example to enable syslog functionality. A lot of the newer devices will support that. So even down in the OT space, look for that capability. We can enable that functionality. Obviously, one of the key things when we look at OT space, especially when we get into motion control type applications, which are done over Ethernet, which is typically non-deterministic, we have to have a way to figure out how, the time offset of that packet. So synchronizing the clocks down to the industrial control system is critical for those motion control applications, but it's also critical for looking at a sequence of events operations, and that I especially want to time into alarm and events. And syslog, it makes another component, right? We got to make sure that our clocks are accurate in the control system, so that when we're reporting up to that syslog server, we've got that event correlation correct. Okay, next slide. Backup recovery.
All right, so now we'll go into backup and recovery solutions. You do not want to be looking for your backups and realize you don't have them when a situation occurs that you need them. You definitely want to be proactively looking at this. And the nice thing about OT-specific backup solutions is that they can alert you also on change management. So we're showing an example here of Asset Center, but you can set up schedules to run. So maybe this runs nightly, and it goes and it'll query the PLCs and the HMIs and whatever you have scheduled to back up, pull the latest program, compare it against the golden copy in its database, and it can do it, email someone, notify you if there's been changes. It can highlight and show you what the differences of those changes are. But it's really key here to make sure you have all of your critical assets backed up. And actually, tying into the OT-specific IDS solutions, some of them actually have the ability to connect to these backup systems and say, hey, I noticed this device on your network, but I don't see it backed up in your OT backup system. And so I'm going to flag an alert to someone to know that, hey, they need to go and change the backup system because you've installed new equipment and you didn't cover it. So this is really nice. And the other thing that's nice in the Asset Center example, if you allow traffic to talk to an API from Rockwell Automation, for those devices, it'll actually tell you the life cycle status and whether, what's the latest firmware available versus what you have in your plant right within that client application. So it can kind of help you along that vulnerability management as well. And because it's a database, it's agnostic in what you can tell it to back up. You can have it back up third-party equipment, robots, whatever you want it to back up, you can tell it to go and run backups for. And the next thing that's very important for all OT folks is you probably have an IT incident response plan, but do you have an OT incident response plan? It's very different. You need to know, who are you calling? Who are the people who are going to be, authorized to make decisions? Tabletop exercises in OT are a great idea, especially because many of the players involved maybe haven't been involved in an OT incident. And you need people to know, do we have a playbook set out? Do we know who we're going to call? If we need to disconnect that IDMZ, so who's authorized to disconnect the OT systems from the IT systems? And make sure you've tested these things out. If you have no idea where to start and you just want to get your team familiar with OT, there's actually a version of Backdoors and Breaches that's ICS specific. And they have online simulators, so you can play with a global team. You can set up a virtual meeting and send people the code for your game and just get people familiar with what are the types of attacks in an OT system and what are the types of things that may happen in an incident response. Another thing to consider in advance is OT incident response retainers. There are many companies you can hire to bring in to do OT incident response, but they give priority to their existing customers who have them on retainer. And so you want to make sure you have this set up in advance so you know who you're going to call in the event of an incident, How is that triggered? And for some of these OT-specific retainers, they actually will allow you, if in 3 years of this retainer, if you haven't had an incident, you can actually take those engineering hours and repurpose them to do tabletop exercises or to review your incident response plans in your playbooks. So it's not just a sunk cost, it's actually something you can use to improve your security posture. But they're definitely advisable to set up in advance and make sure you know how you're going to handle an incident. If you are a small or medium-sized business and you're totally overwhelmed and you have no idea where to start, there are free resources out there for you. Dragos has this OT Cert, which is a fabulous program. It's completely free for anyone to join, but they have templates and things that if you need an incident response plan for OT, they have free templates. If you need, they put out new content every month. They'll link you up with other customers and people in similar industries to you, so you can knowledge share between your peers. But definitely lots of free resources in the industry. Everyone needs to, help each other out to secure the whole supply chain. Yeah. Now, before you walk away, you too can automate your asset discovery. Everything starts with a good inventory and vulnerability correlation there. Adopt a patch management strategy. Know how you're going to prioritize and manage those patches. And then implement those mitigating controls to support that defense in-depth strategy, things like the IDMZ and the network segmentation. Implement that change management and backup recovery. And figure out what your incident response plans are for your OT systems. Now, if anyone wants to come to the mics and ask a question, and please do fill out your surveys. Yeah.
Hi. Thank you for the nice session. So we talk about what controls need to be in place and how we segregate.
Can you get closer to the mic?
There is a lot of holding back that the same IT team cannot manage both the systems, IT and OT. So the question is, if we have all these controls in place, can still that be enabled? What is your view on that?
We've seen some customers actually going to like a hybrid SOC plan, where they have both their IT teams, their IT SOC, augmented with an OT SOC. So there's that kind of flexibility to be able to have OT-specific teams and resources that communicate back and forth. The key thing is that IT and OT really need to have these communication channels set up so that they know how they're going to interoperate.
And I would say that the OT IDS solutions out there have integration, so you can leverage the tool that's designed for that space, and then those can integrate to existing SIEM that you have in place. So then you can have that single kind of pane of glass. If you've got the resources to handle that on-prem and typically on the IT, you'd still ideally have someone assigned and dedicated on the OT side that they would work in concert with.
The other key thing there is the tuning of the OT IDS. So you really want to make sure you've got the OT people engaged when you're tuning the OT-specific tools, so that you know that the alerts and events that you're sending up to Splunk or sending up to other IT tools are really not false positives.
All right. Okay. Thank you.
Just a very quick, very specific question. What are you using for a deep packet inspection? Is this something you've developed custom, or do you have a partner?
So there's three companies that Rockwell has worked with from an OT IDS solution. Clarity, Cisco Cybervision, and we're working also with Dragos. So those are three. Cisco has we've partnered up with a couple different from a next generation firewall. So Cisco has one that we've used and deployed. Actually, that's a Rockwell OEM product, as well as some other partnerships with other vendors out there, traditional firewall vendors that you'll see on the show floor.
Okay. And is there a lot of custom protocol, custom signature development in these environments that you have to do with these engines?
I missed that.
Custom signature development that has to be done for each environment?
custom, well, you'll have to understand, I would say the next generation firewall would need to support the OT-specific protocols. So that's where I would really
Yeah, and
kind of home in on, because that's where, the ability to detect and differentiate a firmware download from going online with that controller, for example.
Thank you.
Yeah.
Question about using certificates for authentication for OT devices. Are there recommendations about how often you would need to renew those certificates? Because obviously you have a ton of devices, it's very difficult to keep track of all those devices, and if someone gets their hands on one of them and is able to extract a private key, then they own access to all of the communications to your devices often, unless you're generating unique certificates for each device, which people don't often do.
So we do provision unique certificates in
Okay.
each device at the time of manufacture. We refer to them like as a device birth certificate or a device identity.
Is it built into the device
It is
in
built
production?
into the device in hardware backed.
Okay.
So there's hardware root of trust backing those certificates.
So you're trusting the vendor's root of trust in that process?
Correct. You are trusting the
Okay.
vendor's root of trust. And just in terms of how frequently to rotate certificates, that is a problem that OT has yet to solve.
Yeah, fair enough.
Currently, I have not seen any OT vendor actually setting the certificates to expire.
Yeah.
Yeah,
and
this,
that's
this
typically
sounds
a
more like
bad-
an 8021 AR situation where you've got like an initial device ID that you just use for the lifetime of the product, I
Yeah,
guess, right?
and the other thing to consider too is in an OT environment, it may not be acceptable to just shut down the device if the certificate expires, if it's a safety system or something that could cause like actual damage.
Yeah, that's
So you need to have like some agreement in terms of how do you handle an expired certificate. You're probably firing off an alert to that IT, SOAR or something saying, hey, these certificates need to be rotated. But you might not want to just shut off the device.
no, it's probably safer not to do it, to be honest.
Yeah.
Thank you.
Quick question. How much of what you just explained applies to your first picture, which was on the left-hand side, so the heterogeneous legacy environments, opposed to what you just talked about? I guess that's much more forward-looking. How much does that apply to
Well,
the
I think everything,
backward-looking part?
yeah, that's a good question. I think everything, when I talk about vulnerability identification, OT IDS solution, that certainly applies because we'll understand what those devices are. As far as the mitigating controls behind that, you're going to be limited based upon that device, as well as the ability to identify it. I talked about bridging through a PLC backplane. The only thing that's traversing that backplane is whatever protocol is being used across that backplane. It's not standard Ethernet TCP/IP based, right? So
Well-
ability to inspect what's out there, that's another key component.
Yeah,
What
and-
I'm trying to get at is that we had a number of nasty controllers who tend to shut down if you ping them. So you would get left with reset devices, and that in the field is a pretty nasty
Well-
situation to have.
Yeah, and that's why it said OT-specific active scans. So you got to be very careful, understand. So typically when we're deploying something like this, we're going to start off with passive and then say, are we getting visibility there? And if not, then we can start to say, okay, what devices are out there? Let's do an Ethernet IP, browse, a scan, which is like, if you're familiar with on the Rockwell side, we bring up a RS links or FactorTalk links and do a RS who. It's just a browse of that network. So we're leveraging what's designed for the manufacturing to minimize, that impact. So it's not doing like an Nmap scan,
Well,
right?
we probably have about half a dozen of control families, and about 90% of them shut down in the way I described it. So no matter how much I want it, it just doesn't work, right? And because of the legacy of Schneider and Omron and Hitachi or what have you, they tend not to respond to these even passive protocol inspections, right?
Yeah, you do have to be careful and understand, especially if that's running, we talked about identifying the crown jewels. If that's a critical operation, you're going to want to be very careful when you're doing any
Sure.
type of active scan.
Okay, thank you.
Yeah.
Bring up a topic that's probably a whole nother session, but just from a very high level, how is the supply chain affecting the OT when it comes to the manufacturing and IDS, whatever, protection of the OT system? Is that supply chain requirements from the federal on down starting to move into this area, having a requirement for these type of security mechanisms in factories now, or is it still in an infancy stage? What is your perspective on that effect?
We see it a lot with the push for software bills of material and how we interact with our own vendors. Our supplier risk assessment process and vetting has definitely changed a lot based on regulations, and it's also supply chain security is considered in things like IEC 62443. So there's requirements for OEMs, there's requirements for system integrators, and there's requirements throughout the entire life cycle of those OT products.
But as far as, impacting some of the controls we talked about today, either detection or prevention type solutions, the impact I see is maybe that device you're looking for you can no longer get, so now you got to figure out, okay, what do I put in its place? And so that could be impactful there.
Yeah.
And it might not be as secure.
With regard to like a sandbox environment and potentially applying some of these either patches or virtual patching, or what type of suggestions do you have with, because it's kind of a heavy lift for some organizations to have a full sandbox environment of the ICS infrastructure. So do you guys have any experience?
I'd also say check with your manufacturers, because for some of the things like Microsoft patches and stuff, we have a Microsoft Patch Qual Lab. I'm sure many of our competitors do as well, and we'll publish which patches are safe to apply, and they've been tested on whichever products, and which ones that were like, please do not apply this patch because this is what's going to break. Yeah.
Yeah, I've got a whole hour presentation I typically do just on OT patch management, because that's a big topic, but only apply the patches that have been tested by the manufacturer. That's a critical piece that we've seen, unfortunately, people ignore, and they actually impact production, right?
Got it. But there's no type of VM environment or any other type of, sandbox that...
Certainly you can develop your own, and we see that with customers, sometimes building out, replicas of different systems. Yeah, the more you can do that, the better off you're going to be as far as now, once applying, you're going to say, hey, I'm going to apply that approved vendor patch. Now let's make sure it's not going to break my system. Right.
Yeah.
Good questions.
Thank you.
Yeah.
This is a follow-up. Can I get a copy of that presentation too?
A presentation that we just went over?
No,
the patch
the
management?
patch
Yeah, talk to me
management.
outside. I can give you that.
Thanks.
Any other questions? All right, well, thanks all for coming.
Thank you.
I've enjoyed the rest of the conference.